Hello everyone, in this video we're going to talk about problems involving polynomial functions. Now for our learning target in this video, I can solve problems involving polynomial functions. Now these are the applications or uses of polynomial functions in real-world phenomena. So we can use this topic in biology, in describing the volume of air in human lungs, physics, in describing the trajectory of projectiles, in expressing energy, inertia, and voltage differences, in weather predictions, in converting Celsius temperatures to Fahrenheit, and in chemistry, we can use this in modeling gas equations. Aside from this, we can also use this in business, in modeling sales in terms of prices of goods and others, in economics, in engineering, in architecture, healthcare, medicine. We have in forestry as well. We can use this in calculating land areas and as well as in statistics and research, especially in conducting studies in labor and employment, modeling population growth. So these are some of the many applications of polynomial functions in real-world phenomena. Now let's gonna have our first problem. The volume of a rectangular block is 88 cubic inches. The width of the block is twice the height, and the length is 9 inches more than the height. Find the dimensions of the block. Now first, let's gonna have our representation. Let h as the height of the block. Thus, we're gonna have height equals h, and width will be represented as 2h based here in our given problem, and our length will be represented as h plus 9. So since it says here in our problem that the length is 9 inches more than the height, so that's why if we translate this, it will be h plus 9. Now let's proceed with our equation. So our equation for volume is length times width times height for a rectangular block. Okay, so now substituting our given representation in our formula, we have the given volume is 88, and for our length, width, and height, we do have h plus 9 multiplied with 2h and with h. Now, of course, we're going to simplify our right side here in the equation that we have. So h plus 9 multiplied with 2h multiplied with h. So we're gonna have 2h cubed plus 18h squared. Next is let us equate our given equation to 0. So we're gonna have this trinomial at the right side of our equation, 2h cubed plus 18h squared minus 88. Then that means we do have our equation h cubed plus 9h squared minus 44 equals 0. Now from here, what are we going to do next is we're going to solve for the zeros of this given equation, right? Or polynomial function. Okay, find the possible rational zeros. Okay, so based on our rational zero theorem, we do have here the factors of our constant term 44. So we're gonna have positive negative 1, positive negative 2, positive negative 4, positive negative 8, positive negative 11, positive negative 22, and positive negative 44. Since the block's dimension must be positive, of course, we take only the positive real zeros here in our list of possible rational zeros. Now, let's use the synthetic division to find one rational zero. The zero is 2. Now again, remember, if you're going to use the synthetic division, whichever solution wherein you come up with zero remainder, then that is what we are looking for. That's the zeros that we are finding for. Okay? So in here, our answer is 2. Now, so let's gonna write our final answer again. The 0 is 2, thus h is equal to 2. Since the height a while ago is represented as h, and width is represented as 2h, and length is represented as h plus 9, what we're going to do is simply substitute the value of h that we've got. So that means we're going to plug in 2 to the representations that we have for our variable h. Hence, the block is 11 units by 4 units by 2 units. Substituting 2 to our representation, so following the format length times width times height for our dimension. So that's it. So we have in here, our block is 11 units by 4 units by 2 units. Okay, so now let's proceed to our problem number 2. The area of the foresail on a 12-meter racing yacht is 93.75 square meters. The sail's height is 8.75 meters greater than its base. Find its base and height. Of course, we are going to start once again with a representation. So we have in here, h is equal to the sail's height, and length of the sail's base is equal to h minus 8.75. This is just a reverse translation of the statement. Sail's height is 8.75 meters greater than its base. And after that, we proceed to our equation. Area is equal to 1/2 base times height. Substitute our representations to our formula in here. So it is stated in here that the area of the foresail on a 12-meter racing yacht is 93.75 square meters. It's already given. So that's why we equate here our given data 1/2 times h minus 8.75 times height with 93.75. Okay? Now we proceed to our computation itself. So since we have our equation 1/2 times the difference of h and 8.75 times the height equals 93.75, we can now simplify or evaluate further 1/2 times the difference of h and 8.75. So what we're gonna do is we are going to multiply 2 to both sides of our equation. So that's why we got h minus 8.75 times height equals 187.5 to eliminate the fraction. Now after that, we're gonna multiply the h.8.75 times the h. So we're gonna have distributive property in here. So we got h squared minus 8.75h equals 187.5. Then after that, we combine the terms and equate to 0. So we're gonna have this trinomial in our left side for the given equation, h squared minus 8.75h minus 187.5. So from here, we are going to factor this out so that we will be able to find the zeros or the roots for this given equation. So we come up with h minus 18.75 and another factor is h plus 10. So getting the values of our variable h, so we found out we got in here h minus 18.75 equals 0, and h plus 10 is equal to 0. Therefore, we're gonna have h equals positive 18.75, and then the other one is h equals negative 10. Now from that, we can have our final answer this way. The solutions of the equations are 18.75 and negative 10. The height of the sail cannot be a negative value, so the height must be 18.75 meters. The negative 10 that we've got, it will be disregarded. So we'll focus with the positive value of h that we've got. The length of the base is then 8.75 meters shorter, or definitely 10 meters. So 18.75 minus 8.75, the reverse process in this statement. So we're gonna have 10 meters. Now moving on to our third problem. After a certain medical drug is administered to a patient, the concentration of the drug C remaining in the patient's bloodstream is monitored. At time t greater than 0, the concentration is modeled by C of t is equal to 1/4 t cubed plus 1/2 t squared plus 25t plus 50. What is the concentration of the drug in the patient's bloodstream after 2 hours? Now again, we're going to start with representation. The concentration of the drug in the bloodstream 2 hours after it was administered is given by C of 2. So now we are supposed to solve for the C of 2. Since we do have our equation already, let's copy the given equation for the meantime, and then we're going to substitute the value of t. Okay, so it says that we are going to find out the concentration of the drug in the patient's bloodstream after 2 hours. So let's plug in 2 to the variable t. Okay, now we're gonna have C of 2 is equal to 1/4 times 2 cubed plus 1/2 times 2 squared plus 25 times 2 plus 50. So with this, simplifying the exponential terms first, so 2 raised to 3, that's 8. 2 raised to 2, that's 4. After that, we multiply. So following the PEMDAS rule properly, so we're gonna have 1/4 times 8, that would be 2. 1/2 times 4, that would be 2. 25 times 2, 50 plus 50. Okay, so therefore, we're gonna have C of 2 is equal to 104. With this, our final answer would be the concentration of the drug in the patient's bloodstream after 2 hours is 104 milligrams per liters. So these kinds of model can help a doctor determine how often a patient should take a medicine in order to maintain a particular amount in the bloodstream. Now for our problem number 4, suppose an open box is to be constructed from a rectangular box that measures 2 feet by 4 feet by 6 feet. Now our task is to find a polynomial function that models the volume of the rectangular box after cutting off x feet from each of the dimensions. And for second task, how much should be cut from each of the dimensions to obtain an open box with a volume of 15 feet cubed. Now let's have our representation. Set up the polynomial function. The volume of a rectangular prism is the product of its length, width, and height. The volume V of x of a rectangular box after x feet has been removed from each dimension is given by volume is equal to length times width times height. So it's gonna be, our length will be 2 minus x, width will be 4 minus x, and height will be 6 minus x. Now from that, we're gonna have our equation as V of x equals. So again, our formula is volume is equal to length times width times height. So let's substitute our representation for length, for width, and for height. So we're gonna have this v of x equals quantity 6 minus x multiplied with quantity 4 minus x and multiplied with quantity 2 minus x. Now, simplify or multiply the three binomials that we have in here at the right side of our equation. We're gonna have negative x cubed plus 12x squared minus 44x plus 48. Now, for our equation, if removing x feet from each of the following dimensions result in an open box that has a volume of 15 feet cubed, then the volume of x can be obtained by solving the equation. So in here, our equation is negative x cubed plus 12x squared minus 44x plus 48 equals 15. Now, let's equate it to 0 first before solving for the zeros of this given function. So I combine like terms for the meantime. So I would have negative x cubed plus 12x squared minus 44x plus 33. Where did we get 33? It's the combination of positive 48 and negative 15. Now, moving on, let's proceed to applying the rational zero theorem. That means we are gonna be identifying the possible roots or zeros that we have for the given equation or function. So since our constant is 33, so our factors are both positive and negative 1, 3, 11, and 33. Okay, so next is, after the synthetic division, we will be able to find out the roots or the zeros are 1 and another one is irrational, or let's say complex zeros or roots. Okay, so now we are going to take only the x equals 1 since the two roots or zeros are complex numbers. Now for our final answer, 1 foot should be cut from each of the dimensions of the rectangular box, since again we got a while ago x is equal to 1. Okay, now for our problem number 5, the amount of rainfall R on the ground at a certain location at time t is mapped by the function where t is measured in days from the start of the rainfall and r is depth of water in inches. On what days did the water disappear completely? So let's start with our solution, our representation again. Water disappears completely when r of t is equal to 0. Okay, if we do have our remainder as 0, or if we're going to evaluate the function, we'll have 0 as the final value. So use the rational root theorem to find the possible roots. So looking at our equation, our constant term is 144. So we list down all the factors of 144, both for positive and negative. Next to that, solve for the possible roots using synthetic division and any other steps that you can use to get the roots of this. Okay, but commonly we make use of the trial and error using the synthetic division. Okay, let us check if t is equal to 2 is a root of r of t. Since r of 2 is equal to 0, it means that t is equal to 2 is a root of the polynomial. Divide r of t by t minus 2 to reduce the degree of the polynomial. Now in here, we're gonna have q of t is equal to t cubed minus 14t squared plus 60t minus 72. And then test another possible rational root on this polynomial. So I'll be trying t equals 6. And here I found out that the q of 6 will now be equal to 0. So it means that t is equal to 6 is a root of the polynomial. So once more, we divide q of t by t minus 6 to reduce the degree of the polynomial again. Okay? So the quotient is the quadratic polynomial t squared minus 8t plus 12, equating to 0, and solving for x results in the following. So let's check if we can factor this out, the t squared minus 8t plus 12. So definitely, we'll have t squared minus 8t plus 12 equals 0. So what do you think are the factors of this trinomial t squared minus 8t plus 12? So the factors are t minus 2 and t minus 6. So equating both factors to 0. So we're gonna have t is equal to positive 2 and positive 6. So with that, the zeros are equal to the zeros obtained earlier. Therefore, r of t is equal to quantity t minus 2 squared times quantity t minus 6 squared. So for our final answer, the water completely disappeared during the 2nd and 6th days. There. So these are the additional word problems that we have for this topic. So you may pause the video for a while, and if you're done answering the following problems, you can now proceed to the answer key provided. So this is our answer key for those 5 problems. Hopefully you understand our topic about word problems on polynomial function. So now, thank you for listening. Hopefully you understand our topic about the word problems on polynomial function. Okay, thank you and see you in our next video lesson.